All right, so here we're doing the same thing. We're going to use an ice table or reaction table to set up how we can mathematically determine our equilibrium concentrations using algebra. Okay, so the first thing we need to do is determine our initial concentrations. We are not given concentration in molarity, but we're given moles. So the initial concentration of H2 needs to be determined, I2, and HI. So the initial concentration of H2 is equal to the moles of H2, which is 0.8 moles, divided by the volume of the liter of the vessel it's in, or the flask, in liters. Here we have 0 moles of I2 begin, so it's concentration of 0. And for HI, we've got 1.6 moles divided by 0.250 liters. So let's determine our concentrations there. 0.8 divided by 0.25 is 3.2 molar. Here we have 1.6 divided by 0.25 is 6.4 molar. Okay? So now that we have our concentrations, our initial concentrations, let's plug them in. This is 3.2. We don't have to put molar there. This was 0, and this was 6.4. Now they said let X stand for the unknown change in molarity of H2. H2 is a reactant and X is positive. So X is also going to be positive here, but the change in concentration is going to be negative for our product, because if the concentration of reactant is increasing, then the concentration of our product must be decreasing if the reaction is going in that direction. Okay? Favored in that direction. So what is X? Again, it represents the change in concentration, some unknown amount that we have to use algebra to find. Okay? If I look at the stoichiometry, X is just, the change in concentration is just X for H2. What will it be for I2? Also X. Okay? As 1 mole of this is made, 1 mole of that is made. But as 1 mole of this is made, or 1 mole of that is made, 2 moles of this are consumed. So the change in concentration is going to be minus 2x here. This is being consumed, so minus, and the coefficient of 2 there is going to go in front. So using algebra, we've determined the change in concentration by substituting that unknown amount, that unknown change for X. And now the equilibrium concentration is going to be equal to this plus this for each column. So 3.2 plus X is the equilibrium concentration of hydrogen gas. X is the equilibrium concentration of iodine. And 6.4 minus 2X is the equilibrium concentration of hydrogen iodide. And so here we are. We've got our ice table set up. And so now if I want to know the equilibrium concentration of this, this, and this, I just do a little math, write my equilibrium constant expression and do a little math, and we can find it. So that is our next step. But now we've just set up our ice table that helps us to be able to do that.